Roger asked me to talk about the internals of Open Toolkit, give a technical talk, and this is about the box inside the box. I'd like to see Open Toolkit as a box where you don't really need to know the details that's inside in order to use it. And then there's another box inside it, which is the pre-processing. If you attended OT Day last year, I gave a talk about it, describing the contents and the different modules inside it. But this year I won't go into the details of what's in there, but rather why it's like that. So here's the Vanity slide. My name is Jarno Elovirta. I'm a DITA hobbyist / amateur because I don't do this as a profession. My day job is writing web shops for companies doing full stack development. You can find me at Twitter. I don't tweet that much, but if you want to follow some of the things that occur in the project, I occasionally tweet about them. And I work for a company called WonderDog, for whom I'm available for commercial projects if someone is interested. So I didn't want to give a one talk that had 50 minutes of technical details because it might have been boring for most people, and I'm not sure if I'd been able to talk 50 minutes about a single topic without it being a rant or some sort of introspection of my history with the Open Toolkit. So this is more like 3 lightning talks about the contents of Open Toolkit. So the first one is why we did it the way it is done right now. And it's not just me or Robert who's to blame, it's also the IBM China, who had a considerable number of years developing Open Toolkit. So there's the history behind Open Toolkit. So we didn't make all the decisions that now play a role in what Open Toolkit is right now. Then I wanted to go into some of the details how we implemented DITA 1.3. Might be of interest to some people, especially since that's the bulk of the work I've been doing for the last year or so. And then I wanted to go through some of the things that I'd like to do or I am currently doing with the Open Toolkit, mostly about optimizations, because those are always fun. And if you have a short question, just shout and ask. If you have a monologue, then you can leave it till the end. So, like I described last year, Open Toolkit contains a section of the processing called the pre-process. It's basically the thing that takes all the input you're giving it, runs it through all the DITA-specific processing tasks that need to take place, and then outputs DITA, which you can then modify using your own style sheets to generate, for example, HTML. And without the pre-process, we'd have something like DocBook, which is just a bunch of XML elements and no actual functionality beyond those, like conref. You don't have something like that in DocBook. And pre-processing is the part of Open Toolkit that resolves all the conrefs, resolves all the key refs, does filtering, does all the things that we take for granted and we shouldn't be really interested in if you're an end user of DITA, but if you're a developer or want to hack Open Toolkit, then it might be of interest. My main focus is in the pre-processing because it's the part of Open Toolkit that has most variety. It's not just a simple XSLT from P to FO block type of mapping. So it has the challenges there I'm work on OpenToolkit mostly because it's fun, not because of for profit. But also, when you implement something in pre-processing, everyone else gets the same, or gets the benefit from it. So if you're doing something with your individual plugin, your individual trans type, you're just benefiting the people who use that specific trans type. But with pre-process, all the trans types that are built into OpenToolkit get the benefit of those changes, but also all the people who have the ultra-custom, corporate-specific trans types that we never see. Okay, so now it's not updating it.
It's the same problem.
Okay.
Yeah, so we need to connect that directly to the projector.
Okay. Could you come and help me with that?
Yeah, for some reason this gets disconnected from the network. So
we need to connect this one to the one.
the adapter doesn't matter.
If we stick it here. I'm experimenting with having my speaker notes on the iPad, and now don't know how this will work.
Maybe it's on the other side.
No. Yeah. Okay. Okay. Just. Yeah.
It's okay?
Yeah. So the technology stack inside OpenToolkit and the pre-processing. We've heard many comments about how Java is an anti-pattern, how Java is ugly and obsolete, and XSLT is the way to go. That's an option and an opinion. I don't necessarily agree with that. One tool doesn't fit all. And part of me thinks that people like XSLT and having it inside OpenToolkit is because it's easy to modify and hack, and you don't need to compile anything. And they already know that. It's simple to get into. So it gives people the easy access to modifying things, not because it's a superior tool for that particular task. So I think we shouldn't choose anything in the Java versus XSLT, or rather XSLT versus something else, just based on the merit of it's easy to modify, and I already know that. And I have a similar comment about another language we're using. So originally OT used XSLT for everything, back in the good old days. Back when I was little and I was implementing my first XSLT processor based on the style sheets that IBM gave us before OpenToolkit was released, 2005, 2004. That's what we had at the time. And they were developed because it was a simple mapping from one step in the processing chain to another. It was simple. And then at some point, the developers at IBM China started to modify the code so that they used Java for some of the processing. They used various XML APIs for that, or Sax and DOM, really. I don't know why they chose those, but it might have been because XSLT is a functional programming language. You can't modify the results. You always need to create a copy of things. So maybe the developers were more familiar with Java, and that's always what you get in a project. People working on the project bring their history with them. So if they know Java, they probably use it. If they know XSLT, they say Java is not good for anything. So we still have some places where we need to choose between the technologies we use in OpenToolkit. We occasionally add some new functionality into the pre-processing that wasn't there in the first place. And when it's new code, you have the option of choosing. With old code, you're stuck with it, or then you have to re-implement it, and re-implementing usually takes time unless you have magic on your side. So there are places where Java, and in this case I'm mostly talking about Sax, makes more sense, because XSLT has the package of it's trying to be immutable, in the sense that if you access another document with XSLT, you will always get the same document back, which means it needs to keep it in memory, and you will run out of memory at some point if you have, let's say, 3,000 topics, or nearly 100,000 as with one of my customers. So sometimes you need to choose the technology based on the constraints instead of the good bits that it gives you. In these cases where running out of memory is an issue, for example, DOM might be a better solution, because you're able to throw it away once you finish with the processing. And Sax for pure filtering. XSLT3 has some, or not some, has streamability capability. It can stream, but we're not using XSLT3 yet. We're actually stuck in Saxon 9.1 because ODT plugin uses Java extensions. So we need to refactor that in order to upgrade to a newer Saxon version. And again, remember, when this project got started, it was XSLT 1.0 days. So again, we go to that, if the code already exists, you can't really update it without rewriting. Yeah. No one has any questions? No? So, when it comes to Java, we're using two XML APIs for processing XML, because internally OpenToolkit uses XML. What goes into OpenToolkit doesn't need to be XML. It can be Markdown, it can be anything really. DITA class has shown us that you can just stick anything into OpenToolkit that it will be able to process it, because it converts it into XML at some point, and internally everything flows as an XML document. So we're using two XML APIs, Sax and DOM. I wouldn't use DOM if I were able to choose now. DOM is it's an XML API that was developed to be platform independent, which means it's bad in every language, every programming language. And since we are using Java, we'd like to use something that was designed for that particular language or those particular needs, because DOM also has the concept of, for example, live lists. If you ask for a list of elements and then you delete one in that list, or delete one element that is in the tree, the list gets updated. So it works in a browser when you're working with JavaScript and so forth. It doesn't really work that well when you just want to modify it, almost like XSLT, that you have one tree coming in and the other one going out, and you don't want to do updates into the tree while you're working with it. So we're using Sax and DOM because those were available when OT got started, and those are used for their characteristics, where Sax is a streaming API for XML, meaning you get events like start tag, some text, end tag, and once you've received those events, they're thrown away. So it streams through the XML file and it doesn't retain it. so it doesn't retain any of the information once it's done. DOM, on the other hand, builds a tree and keeps everything in memory, which means it can cause your JVM to run out of memory. So IBM China at some point were really keen on using string readers and string writers when processing XML. That's a really bad thing. So we've been retrofitting that code to use just SAC streams or pure DOM for security. And SACS works really nice when you're doing, in a way, mapping operations on the event stream. An example of a nice mapping operation is when you're resolving code refs. You're processing the document, you come to a code ref element, you resolve the code ref reference, take the results, meaning the text that is code, pass that along, and then just continue. You don't need to keep anything in memory. So that's where SACS. So it keeps changing the slide. Sorry. Where am I now? Okay, yeah. Whereas with DOM, sometimes we do want to modify the document as we're going along. A bad example of this is the chunking code that goes through the document. When it finds something to chunk, it modifies the tree. It's a bad example because the chunking code is really bad, and it might be better if it was re-implemented in some other type of approach. But it still works because you're able to modify it at runtime. But the problem with choosing any XML API or any technology is that once you select it, you're stuck with it. Or if someone else selected it for you, you're still stuck with it. So Open Toolkit is quite I/O expensive I/O, meaning input-output, meaning reading and writing. That's because it's architectured to be a series of modules that modify the contents of the previous state. And that means we're passing XML from one step to another. And between every transition from one module to another, meaning in AND terms, from one target to another, you have to serialize everything to disk. And then when you start with the next module, you read everything in again. And that's how it worked in the beginning, and then someone added extension points. And now we can't modify it because someone may rely on that extension point, that it's there. So we need to keep everything split. In the future, I hope we'll be able to take some of those extension points out, because I want to make pre-processing a black box that no one ever touches. They just use it. And that way, when we have the ability to change everything nilly-willy, we'll do that. And then hopefully the end result is that we don't need to read and write XML all the time, but rather we can just stream the content through in memory when it's possible. But there's the catch that you may run out of memory, and some people feel that RAM is cheap. Buy more RAM. You have 38 gigs of RAM, just use it all, but it doesn't really work like that. And just because RAM is cheap, it doesn't mean that we have to use it all. So we can still architect our software to not assume that everyone is able to upgrade their laptop to give it more memory. And that's why I'm sort of hesitant in pushing XSLT for everything. There are things that null my opinion, because with Saxon you have the option of using an extension that throws away the documents from memory. But then again, I don't want to rely too much on extensions either. Elliot has a...
Yeah, I'm not sure where the microphone is. So, I mean, this is certainly a subject where Jarno and I have either different opinions or simply differing optimization requirements. I'm certainly of the only way I can do what I need to do with DITA is to have it all memory at once. There are certain processing tasks for which that is the only way you can possibly work, right? So I'm not sure that we can actually make. I don't think it's possible to say, oh, well, we can implement it so that it, minimizes memory use, or we can implement it so that it minimizes I/O. I think, in practice, the system has to allow you to choose both ways. Right? So I should be able to configure the open toolkit and choose a set of processing options that minimizes memory use when I have that 100,000 topic use case. Right? That's actually a real use case. And I have clients that have 96 gigabytes of RAM on the server. Yeah, they can handle that in memory, but that's included. On the other hand, most use cases are not 100,000 objects. Right? They're processing that can be done within, say, 40 of RAM. We can do it today for, say, 20,000, right? Or 10,000 copies, or reasonably sized publications that represent 500 pages of content. Right? So, I would have to be optimal in its processing. To do that, I want to put everything in there. Right? So, ideally, I should be able to choose. In terms of the final output stage, I can make that choice myself because I have control of that final output stage. I can implement that however I want, right? I can do everything in memory and SSLT or not. In the pre-processing stage, the degree in which it's a black box of which I have no control limits that. And so, as the architect of pre-processing going forward, I would urge us meaning the open toolkit team, and in particular, to find ways to give us that choice between maximizing speed and maximizing minimizing memory.
I've been drawing diagrams about this. You have three things, choose two. So which do you want? They have a theorem. So you can have speed, but you can't save memory at the same time because memory actually gives you part of that speed. So you're right, it needs to be a toggle that you can switch. And that's what Open Toolkit currently has with conserve memory or some other argument. So if you switch that, it starts to use the Saxon extension that throws the documents away that it's read using document function. So it's already there. But when you're actually implementing it, you need to keep that in mind, that you can't choose something that excludes that possibility of toggling whether to have the speed or have the memory usage. So which is more important for you? I suppose with XSLT and with something else, in this case Java, because OpenToolkit is implemented on top of JVM and uses Java. I suppose both options are possible, everything in XSLT, and you have the toggleability. Toggleability is a nice word. Or you use Java to do almost everything. But then again, you choose.
I mean, the other challenge of using Java is that it makes it much harder to provide extension points that people can then use easily to extend.
Only if you're afraid of writing Java. So if you've implemented something in Java, right? It's easy to extend if you write your extensions in Java. And then with extension points, you always have to design those. You can't just add them just because you might feel like you have to design the extensibility. And the way the original extension points worked, you were able to stick those extension points between all targets in the pre-processing and flow. But that requires you to serialize everything between those steps. But I'll get sort of back to that if I have time. I should probably talk fast. So this isn't a quote by Linus Torvalds. This is just a general idea that if you don't have anything nice to say about something, you can just be quiet. This is where my speaker notes would come in handy. So, Open Toolkit uses basically 3 technologies: ANT, XSLT, and Java. And ANT here is used for configuration, for managing the flow of operations, meaning it's the configuration language for Open Toolkit, and in some cases it's the language that is used to do some simple operations like copying files. ANT is a build tool that was released, I think, in 2000. It was generated to make it easier to compile Java to replace make, and it works really well for that purpose. Or rather, it worked really well in 2000 or 2001. But then the world moved on, and no one's using Java anymore, except us, because we're stuck with it, because our plugin system uses that. For example, DITA-OT itself uses Gradle to build Open Toolkit's Java code or create the distribution packages. So ANT used to be good. It's not that good anymore, or something better is there, and I think we might want to start to move to that direction more. The problem is that every plugin in Open Toolkit consists of a plugin file, plugin.xml, that tells you which ANT file to use for driving the whole process. And if we start guiding people to not do processing related things in ANT, but rather use XSLT or Java or something else to do those things, then we're able to at some point throw ANT away or replace it with something behind the scenes, like during the integration phase, read in ANT, convert that into something else, and then not have ANT be the bottleneck for the processing. But like I said, ANT was good at the time when it was invented, but not anymore. And ANT is a sort of it's a build tool that's been made to build software packages, and it's not a general purpose language. I wish I had my speaker notes. So the thing with Open Toolkit, it's not a general purpose processor for XML. It's specific to DITA, and we should be able to take that into account when choosing something, what to use. It's just like xproc. Xproc doesn't use ANT for its configuration syntax, because why would it? It's using something custom for xproc. The same, in a way, applies to Open Toolkit. So, I don't remember what my next slide is, but does anyone have questions related to the pre-processing part? I need to start moving more quickly, sorry. So, things that changed for 1.3. I think, oh, well, that's so sorry. Yeah, okay, not a problem. So, most of the things that we implemented for DITA 2.1 and 2.2 for DITA 1.3, did I get that right? Were some things that we did in pre-processing. The XSLTs for PDF or HTML didn't change that much. They're pretty much the same. We just had to add support for for example, div element or something like that, but most of the work went into pre-processing. And the architecture of the pre-processing didn't have to change. We still had the same approach of having modules that follow each other and modify the documents. But the order of the pre-processing steps had to be changed, just because it was impossible to implement 1.3 with the old setup. So, for example, same topic fragments. You can implement this in XSLT, but it's a lot faster to implement it in Java with using sacs, because this modifies a single attribute, and the only state it needs to keep in memory is which topic did you encounter last, or the ID of the topic. So it's a really simple stream, and this is sort of a textbook example of when to use sacs. It can be done in XSLT, but I don't see any reason why to read the document into memory when you can just stream it. Radu discovered that the initial implementation had a bug in it with conrefs. So what it now does, it first actually resolves the same topic fragments in conref attributes only, right in the beginning of the processing. Then when it's processed all the keys, then it goes for the href attributes. So it's run twice, the same sac stream. And if you want to get into Open Toolkit code, looking at this might be a good example of seeing how things can be done, or if you at some point want to extend OT with your own processing. Branch filtering, your baby. Yeah. Looking at Robert. So, if I remember correctly, DITA allows branch filtering to, in a way, take place at the same time as the existing filtering, or as two separate steps. And the order of those two steps isn't mandated by the specification. And OT implements this separate from the normal pre-processing, from the normal filtering. The existing filtering that uses DITA-val as an argument to OT, that's the same, hasn't changed at all. And this takes place after few of the pre-processing steps have been made. Because internally what it does, it takes the DITA map, then it duplicates all the branches that are configured by the DITA-val elements. And then it filters each branch separately from each other. And this required us to move the map merging to take place before branch filtering. And now map merging is actually done in the very beginning of the processing. It used to be in the sort of midsection of pre-processing in order. You shouldn't see it. You shouldn't see this change at all. This was actually one of the first things I implemented for DITA 1.3 support, because key scoping wasn't finished at the time. And I assume that this works fairly correctly in OT22. But since OT22 is, in a way, the initial implementation, there are bugs. Every piece of software has bugs. When you find those issues, report them. So scoped keys. This took me really long to be able to understand how it should work. Talking to the various TC members about how does it work. So implementing this was actually probably the most difficult thing in DITA 1.3 support. And original Open Toolkit design just read all the keys into a single map in the beginning of pre-processing. because you only had one scope, so it doesn't work anymore. So now you have to merge the map to have all the information easily available to the code, and then you just construct these multiple maps into a tree, and it's sort of a scope tree where each scope is the map of the keys. So in a way it's quite similar, it's just that instead of having a single map, it's a tree of maps. And the interesting bit with key scopes is that you inherit from parent scopes, or was it the vice versa? So implementing this means you have to cascade keys down and then up and then down. So it's actually doing quite a lot of work. And again, this could be implemented in XSLT, but I think it's easier to do it in Java. And the OT22 implementation doesn't implement all the corner cases. I know that for a fact. But in my opinion, when you read the book DITA, the good parts, it doesn't list these corner cases. So normal usage will never find that Open Toolkit implementation is missing the functionality to process those. Both scoped keys and branch filtering do the same thing as chunking. It generates new resources. So we actually now have some code that generates new topics, because if you have two files in two different scopes, they resolve to different keys. Those are not the same anymore, so you have to actually duplicate content. And we haven't made the ID rewriting or the file name rewriting customizable yet. So now I think it just uses hyphen and then an index for the duplicate copy. But at some point we'll probably make that a configurable option. I don't know if file names are that important for you.
So, Jarno, my comment on that is that file names for that are essential, and if I don't have control
Could you give
over
it?
them, I cannot use the open tool. My comment is that in that particular case, I must be able to have complete control over the result file names of the resources that are generated through the implicit, that is, the resources that are implied by branch filtering and key scopes. I must have control over the file names because I need to preserve them in my generated output. That is, for two different revisions of the same publication, I make sure that the generated resources have the same, have the same file name in the generated output, HTML, whatever. So that's why I have what's the name of the pre-processing extension that I wrote. The copy to pre-process extension, right? That was my short-term hack for completing that. But if there was a more complete and more general solution in pre-processing, that would be more better.
Yeah, I mean, if we do the ID generation in XSLT, it's easy to extend if you know XSLT. I think there should be another way of doing it. I don't know, perhaps via patterns of rewriting, regexp type of patterns. But then remember the result file names, for example, something.html. Preprocess doesn't generate that. It's the transtype specific code. Transtype specific code is always free to choose any file name they want. They can construct the file name from the title of the topic, lowercase everything, normalize white space, replace every white space with a hyphen, and you get a search optimized file names for that. So remember that it might feel like it has to be done as a plugin to the pre-processing, but in some cases you can solve the same issue somewhere else, for example in transtype specific code.
Yeah, so just in the work that I did to generate any output transform that generates HTML will then just transparently reflect my policies for me.
Yeah. I should have been more explicit. When I say stick something into pre-processing, it doesn't mean stick it inside the box. Stick another box after the default pre-processing that modifies something, and then your trans type specific code. So it doesn't have to be inside the box. Because some of the optimizations that I've been playing around with are impossible because of the backwards compatibility and the need to allow people to modify the pre-processing code. Let's try and go for it. I think I have 5 minutes. Yes. Okay, good. Because we don't need to discuss these things here. We can just talk about them afterwards. But like future work, what we're planning for Open Toolkit for 2.3 and 3.0. So my preferred approach would be to finish DITA 1.3 support in 2.3. Just fix everything that's broken. If the TC decides to change DITA during a month now, we'll fix that in 2.3. And then for 3.0 version of Open Toolkit, we'll break everything and do the fun bits. So one of the things that I'd like to do for 2.3 or 3.0 is add some libraries that we're depending on, like update Saxon to a newer version, since Saxon, the latest version of Saxon might actually be a lot faster. I don't know, I haven't really tested. Take, for example, Guava, a Java library into use to make the Java code more pleasant to work with, and stuff like that. And then I'd really like to remove some of the extension points from pre-processing. Like right now, I can't remember the exact details now, but you have extension point like that allows you to run some code after the map link stage. But we actually changed the code so the extension point is there, but now it's ran before when it was supposed to be ran after. So we broke some rules already, and breaking those rules is bad. So it would be nice to just remove some of the extension points that don't make sense anymore, that we have better ways of doing it. Or then if they're just in the way, remove them and people are hurt, but you can't always please everyone. And then if there are some things that we can still do in the pre-processing, move it there from the normal trans type specific code. Like right now we have index processing in HTML, or well, HTML help, and PDF. We could just merge those into a single step and do it during pre-processing. And then a step that I'd like to do, or thing that I'd like to do that has more to do with how the plugins are maintained, is to take all the plugins that are right now in the DITA-OT Git repo and stick them in their own repos, so that we'd be able to develop and release those in a release schedule that isn't tied to Open Toolkit. That of course opens additional issues, but from managing plugins it makes sense. And then update to Java 8, because Java 7 that we're currently using is already end of life, so Oracle doesn't support it anymore. No public updates. Optimizations, this is actually the most important one, or the most interesting one. So the things I've been working on that might land on the actual OT code at some point is that instead of reading files, we abstract that to the Java code processing, and in this case Java code means the code that processes the modules inside pre-processing. we just talk about Java source and result objects, which means we don't have to have a stream source and stream result that read and write to XML, but rather we could just use, for example, DOM source and DOM result under the covers. The XSLT wouldn't notice anything. It would still run exactly as before, but you're actually never serializing anything to disk. So we'd be able to, using a toggle, decide whether we want to keep everything in memory all the time or whether to serialize. Then another thing that is quite interesting is generalizing element names and rewriting the style sheets to use the element names instead of having an asterisk for every pattern and expression in XSLTs. I haven't really measured things, but it seems that it might, in some cases, give you twice the speed, and in the end, no normal plugin developer would notice this. We would actually do the rewriting during integration phase. And then combining modules to actually face each other directly. So you wouldn't serialize anything. If you have two modules that are both SAC streams, you just pipe them together, never serialize anything in between, just because someone wants to use an extension point. But some of these things are difficult to implement, and the problem with optimizations is that you have to implement it first, then measure, and then find out that it didn't work. It's not faster. It's really frustrating. Like, I wrote code that does parallel processing, so it takes an XSLT, or in the old system, it ran XSLT one at a time. Then I changed the code so it runs 8 XSLT processes at the same time. It's not that much faster because it's I/O bound. So sometimes you spend a month doing something and then you notice it doesn't work as well as you expected. And similar things were, for example, I thought it might make it faster if I take all the topics, stick them into a single file, wrap it in a DITA element, so you wouldn't need to read all those files separately. That didn't help at all. It's not faster. So that's the problem with optimizations. After you've measured, you know if you succeeded, and sometimes you don't. We'll discuss this later on, if someone wants to, or if Elias still has ideas. Okay, thank you.
Thank you.